Today we're going to talk about mixed expressions. Okay, this section you'll find a lot easier than last sections because the kind of expressions you get is something like this: 3t minus 2 over t. Why is this sort of question nice? Whereas it's not adding or subtracting two fractions, it's a monomial minus some fractions like this. Why is this nice? Yes. Right. So all you have to do is, what is the denominator of 3t, guys? 1. It's that invisible 1. So since the denominator is 1 and the other denominator is t, it's easy to really add them together. Because it's easy to figure out what the LCD is. What's the LCD for this class? T. So all you have to do is multiply 3t over 1 by what? T. Not t, but t over t. Does that make sense, Claire? Okay, so what do I get? The first fraction becomes?
No, 3, right?
We have 3t over 1. So what do we need to multiply top and bottom of this 3t over 1 so that it'll have the LCD of t?
T.
So not t, but t over t. So what does that become? What does it become?
3t squared over t.
Exactly. Is that okay, guys? Yeah. And notice I changed everything to addition, right? Because I don't like subtraction. Go ahead, everybody finish it up. It shouldn't take you too long. So who could tell me what we get here? Chuck?
3t squared minus 2 over t.
Exactly. And can we do anything more with this expression?
No.
Can we simplify this further? No. Because numerators you can't factor out anymore, right? And that's all you could do. Do you see how these are pretty straightforward? So you're going to get monomials with another fraction, and it's really easy to figure out the LCD because if you have a monomial, it's something that monomial over 1. Does that make sense? All right, let's look at a second example. Okay, this time you have x over x minus 1 minus 5. So what is really 5 in terms of a fraction? 5 over 1. So you could already see what the LCD is. But every time you get something like this is really easy. Who could tell me what the LCD is? Samuel?
X minus 1.
Yeah, x minus 1 is your LCD. So you're going to do what with the 5? 5 over 1? What should we do with 5 over 1? Multiply? Yeah, multiply the numerator and the denominator by x minus 1. Go ahead, everybody try. I'll wait. You should be able to do this without much problem. All right, who can tell me what to do next? Eric?
Yeah.
What do I do?
Oh, I did. For the least common denominator, I got
Yep.
x minus 1, so
Yes.
I multiplied x on both sides.
You multiply
X to both sides.
x to both sides?
Yeah, but that's wrong.
Right, right, that's wrong. Okay, you have x minus 1. You just told me that x minus 1 is my LCD. What is the denominator of this 5? It's 5 over?
1.
So what do I need to multiply 5 over 1 so that we have a common denominator, least common denominator of x minus 1?
X minus 6.
What?
No, x minus 2.
You need to multiply top and bottom of this 5 over 1. Let me show you.
I know.
So I changed it to addition, right? What do I need to multiply top and bottom of this negative 5 over 1 by? Because it's subtraction. Yeah, x minus 1 over?
X minus 1.
Yeah, does that make sense?
Yes.
And do you see how I change everything to addition, guys? Because I don't want to make silly mistakes. So then when you do this, you simply get x over x minus 1 plus negative 5 times x minus 1. Of course, you could distribute that. Did you all get x plus negative 5? Oops, one more here. X plus negative 5, right? When you distribute this negative 5, both of these. Plus 5?
Yeah.
Okay, it's plus 5, isn't it? It's not negative 5. Okay, yeah, because you're distributing the negative 5. So, yes, the whole thing becomes negative 4x plus 5 over x minus 1. Any question? Eric, do you understand how that works out?
Yeah.
So these are a lot easier, right, than the ones that we did last time, right? Because the denominator of one of the fractions is 1, right? When that happens, it's really easy. All right, let's move on to the next one. Okay, example 3. This time, you don't have two terms adding or subtracting. You have 3 of them. X minus 3x minus 1 over x minus 2 plus 5 over x minus 2. And again, one of the fraction has denominator of 1. The other two fractions, it's kind of nice. They both have x minus 2 as its denominator, right? So you could easily see, that the LCD for this is what? How about Paige? X minus 2, right? So all you have to do is, for the first term is x over 1, so multiply the numerator and the denominator by what, class?
X
Minus 2 over x minus 2, right? Then you would have all three of the fractions to have a common denominator, right? LCD. Go ahead, everybody finish it up. Dana, can you tell me what to do? Okay, let's listen. Go ahead. Correct. Did you all do this? Also, did you guys change the subtraction to addition this way? Because you got to distribute this negative 1, right, to the two terms on the top, right? So next, when you do this, Tajwar, what did you get on the numerator?
On the numerator,
Yeah. What's my next step? Let's write them out.
that's x squared
Uh-huh.
minus 2x.
Right? Plus?
Negative 3x
Uh-huh.
plus 1
Good.
plus 5.
That's right. Did you all get this? So you get x squared minus 2x minus 3x plus 1 right here, okay? Because you got to distribute that. And plus 5 all over x minus 2. When you simplify the numerator, Elder Samuel, what do I get here?
X squared minus 5x plus 6.
Correct. We get x squared minus 5x plus 6, and we're done, right? No, because whenever you have a trinomial, what can you do with this? How about, Patty? You can factor it. We've got to check and see if it factors. You may not factor it, but does it factor? Yeah, how's it factor, Patty?
X minus 3, x minus 2.
Good. It factors 2. X minus 3 times x minus 2. And notice, we have x minus 2 as a factor, right? On the numerator, of the whole numerator. And you got x minus 2 on the bottom here. They cancel out. Whole thing becomes x minus 3. Any questions?
I got it right.
How many people got x minus 3? Raise your hand.
This one?
Okay. How many people now see your mistake? Okay, some of you still don't. Okay, go ahead and help each other out. Some people still not got this. Still don't get it. I'll wait. Go ahead, everybody. Help each other out. This is the answer, guys. All right. So a lot of you forgot to distribute this negative 1, right? The second fraction, when you change this to addition right here, right? It becomes plus negative 1 times this binomial. Make sure that you get negative 3x plus 1 here. A lot of you left it as still negative 1, right? Then you're just subtracting the first term, not the whole, right? Second fraction. Okay. All right, may I move on to the next example?
Yeah.
Okay, good. Here's example 4. This example 4 is kind of interesting because we haven't been multiplying fractions so far. But this one has subtraction and multiplying the fractions together. But actually this is not that hard. Yeah. So it says y minus 2 over y plus 1 times 1 minus 1 over y plus 2. So write it down and think about what you need to do. Do we still have to follow the order of operation?
Yes.
Yes. So we have to deal with the parentheses first. Then after you simplify what's inside the parentheses, right, you multiply those two expressions together. Okay. Let me ask you something, class. What do you think the LCD for this fraction will be? Okay, Lindsay, what do you think?
For the first one, this is y plus 2.
Good. The first one is y plus 1.
The second one is y plus 2.
You're exactly right. For the second one is y plus 2. Do we need to worry about the denominator of all of these? Y plus 1 and y plus 2? In other words, do we need to get an LCD for all the fractions that you see here? No, because you'll be subtracting the two fractions, right? In the first parentheses, and then the two expression in the second parentheses, right? Because when you multiply two things together, do you need LCD?
No.
No, so you just need to be able to subtract these two, and then to subtract the last two, right? Does that make sense? So, just like Lindsay said, what are we going to do with the first fraction? It's really y over 1, isn't it? So, and then it's 1 over 1. And notice I change it to addition, so it becomes negative 1 on the numerator. What do I need to do with y minus y over 1 here? Jenny, what do I need to multiply top and bottom by? Y minus 1 by? Exactly. I need y plus 1 over y plus 1. What about the other one? 1 over 1? Song, what do I need to multiply top and bottom of this by? Y plus 2 over y plus 2. Does that make sense, guys? Sometimes people see this and they go, oh, isn't LCD y plus 1 times y plus 2? No, that would not be true. If we were adding all four of these, then yes, that would be true. But we're multiplying these first two expression and then multiplying the, we're subtracting first two expression and then subtracting the last two, and multiplying them together, right? So you don't need LCD for all of these, right? You just need LCD for the first two and then the last two, separately. You get that? Okay, go ahead, everybody finish up, and I'll wait and help each other out. Work as a group, it's fine. All right, so who can tell me what to do next here? What we get? Eugene, tell me what to write. So we're multiplying y over 1 times y plus 1 over y plus 1. What does that give you?
Y squared plus y
Mhm.
over y plus 1
Mm-hmm.
plus negative 2 over y plus 2.
Right, and then here is just y plus 2 plus negative 1, right? So you could write it as a one fraction, right? Because they both have the same denominator, right? Are you okay with that? So we get y squared plus y minus 2 for the first fraction over y plus 1. The other is just becomes y plus 1 is really what it is. Okay, isn't that just y plus 1? Right, guys? Because you get y plus 2 plus negative 1. All right, look at the trinomial on the numerator. Does it factor?
Yeah.
Because if it factors, we should factor that. It does factor. What's it factor to, Bella?
It factors to y minus 1 times y plus 2.
Correct. So since it factors to y plus 2 times y minus 1, nice thing happens, doesn't it? Now we have factored the whole numerators. Look, could I rewrite this using the commutative property of multiplication? I could write y plus 1 over y plus 1 times y plus 2 over y plus 2 times y minus 1 over 1. Isn't that the same thing?
Yeah.
What is y plus 1 over y plus 1, class? 1. What's y plus 2 over y plus 2? So I get 1 times y minus 1. What's the answer? How many people got y minus 1 as the answer? Okay, if you didn't, go ahead and fix it. Help each other out. Okay, I'll give you time. Go ahead, guys. If you didn't, a lot of you got it, but go ahead and fix it.
I got it. Oh.
Seems like a lot of you are getting this. I'm going to leave this up here. Example 5, I'm going to have you do it by yourself. If you really got this, you should be able to do this without any problem. Let me ask you something though. What is the denominator of x minus 1 in this problem? 1. Okay, good. Keep that in mind. Go ahead, everybody try. I'll have you do this by yourself from the beginning. And of course, if you get stuck, you can talk to your group. That's fine. Okay, go ahead, everybody try. No, it's not. It's not a trick question. It's just, I just want to know if you could do this yourself. First, try it by yourself first, okay? But at the very end, if you get stuck, you could ask your group. But see if you could do this by yourself, okay? All right, so who can tell me what to do first? How about, hold on, how about Claire? What should I do?
You should make the denominator
Right?
x plus 2. So you multiply x plus 2 over x plus 2
Mm-hmm.
on the left side.
Right. Sorry. Yes, so I'm going to multiply top and bottom of the first fraction really is x minus 1 over 1, right? Multiply by x plus 2 times x plus 2. Good, then what do I get when I do this, Jason?
Oh. You get. I multiply the x plus 2 and x minus 1.
Yeah, you need to multiply this out because you can't really do much here. You got to gather all, you have to, right? Subtract all the numerators and then. So what is x plus 2 times x minus 1? What did you get?
X squared plus x minus 2 over x plus 2.
Okay. Actually, when you multiply x minus 1 times x plus 2, don't you get x squared plus 1 minus 2? Oh, sorry. And then when you change this to addition, this is plus negative 1 times this, right? You got to distribute this negative 1. Did you get negative 2x minus x plus 5?
Yeah.
Okay, so when you simplify all this, what did you get? When you simplify the whole denominator?
3 over x plus 2.
3 over
X
x plus 2. How many people got 3 over x plus 2? Okay, that is the right answer. That's it. Okay. Can we cancel out any more? Or can we simplify more? No, that's it. That's all we could do. Yes.
So you're supposed to change it? That, I mean, you know how it's x minus 1 and you distribute it?
Right. So I'm distributing negative 1 to this. Yeah, so it becomes opposite of what we had before, right? Because look, we're subtracting this whole fraction, right? So it's plus negative 1 times the whole thing. Okay. Any other question? Are we good? Can you do something like this for your homework tonight?
Yeah.
Okay. All right, good.